The example that we have up on the board is actually just a basic electrical circuit. It has a voltage source. We're going to examine the current that's flowing through the circuit, and we also have the circuit resistance illustrated by the resistor symbol. As long as the switch is open, there is no current flow through the circuit. That means that the resistor has no current flowing through it. Closing the switch, now have current flowing through the circuit, and we're going to find out how to calculate different circuit values, and eventually we'll work into calculating the power dissipation of the resistor itself. In this example, we're going to take a look at 10 volts. We're going to apply it across, say, 5 ohms. And in using Ohm's law, we're going to take this, we're going to calculate the circuit current, I, which is the intensity of the currents, equal to the voltage divided by the resistance. In the case of this application, our current then will be 10 volts, and divided by 5 ohms, and it's going to result in 2 amperes. If we took this particular circuit and wanted to calculate, say, the resistance, we could take the voltage divided by the current, which is 10 volts divided by 2 amperes, and come up with 5 ohms. So it works out very well. If we want to calculate to check and see if our voltage is what it's supposed to be, we can always take the circuit current and multiply that times 5 ohms. Find this value here, the voltage current, times resistance. We're going to have 2 amperes times 5 ohms. This is going to calculate into a voltage being applied at 10 volts. Now, the circuit itself, when we're talking about the resistance out here, primarily we're focusing on what the power is going to be dissipated by. We're going to say that the wires themselves, the conductors, are all capable of handling the load of the current. The voltage source is assumed to be capable of supplying whatever energy as in form of current that it needs to dissipate and flow in the circuit. We're going to take a look then at power dissipation of the resistance, because assuming that's usually what is calculated in the circuit, it's just a circuit resistance or whatever type of resistor or load. It could be a motor, relay, lamp, and it's going to be included as the total circuit resistance. In this case then, we're going to look at 3 different forms of the power formula, and this refers to just how much power the particular load here is dissipating. The first formula is voltage times the current. The next one, power is equal to V squared over R, and the last one is going to be equal to I squared R. So if you take a look at the 3 different forms here, primarily we're going to take a look at this application up here, and maybe this one down here as far as the power. Power in electric circuits is calculated as watts. That is the actual unit of electrical power usage. So in this case, we're going to find out how much this resistance has to dissipate. Power is going to be in the form of heat, and that heat is going to be calculated in watts. So in the first case, where we have the power voltage times the current, power then will be equal to 10 volts. The current was calculated at 2 amperes. So the power in this particular case is going to be 20 watts. 20 watts of dissipation by this particular resistance. Say we want to use one of the other formulas. Let's use P is equal to V squared over R. We're going to set this formula up here. V squared divided by the resistance, plugging in the values, would be 100. 10 times 10, or 100. And we're going to divide that by the resistance, which is 5 ohms. 100 divided by 5 then is 20 watts. In the third variation of the power formula, we're going to see how we can use I squared R. In this particular one, I squared R, we're going to actually take the power, and it's going to be equal to 2 amperes squared times the resistance, which was 5 ohms. I'm going to come down here then, power is then equal to 4 times 5 ohms, or 20 watts. This is our 3 variations of the power formula, and this is how it applies to circuits applications. You can actually have other resistors, and here we'll cover this in a later session, series and parallel, and calculate power for all of those devices. This is a variation of Ohm's law. It works very well for the calculation of both power, voltage, current, and resistance.